So now we are solving exponential equations, and we're going to be using without like bases. So just solving any exponential equation. So we need to remember our exponent rules, and a lot of times I'll have those written on the board, but when we have a power raised to the power, so if we have like x squared raised to the third, what does that equal? What do? We multiply the exponents. So this becomes x to the 2 times 3, or x to the 6th. Now, when we're multiplying, we want to keep the base and add the exponents. And I have a few quick examples here. 3 to the 4th times 3 to the 4th. That's not 6 to the 4th or 9 to the 4th. That is 3 to the 8th. We add the 4's together. When we have 2 to the 4x times 2 to the 5th, that is 2 to the 4x plus 5 power. And then finally, we have 2 to the 3x and 4 to the 2 minus x. So first we need to have them have the same base. So this is 2 squared to the 2 minus x. And so when we have a power raised to the power, we have to multiply those. So that's 2 to the 4 minus 2x. And this one is 2 to the 3x. So that becomes 2 to the 3x plus 4 minus 2x, because we add the exponents, which ends up being 2 to the x plus 4. Okay, so that third one is a little more difficult because we had to get like bases and then use our exponent rules, power to a power. So now let's go through some of these examples. It says make sure both sides of the equations have the same basis, then solve for x. Remember to use your exponent rules. So if we look at number 1, x, or 6 to the negative 3n times 6 to the negative 2n equals 36. So that's 6 to the negative 3n minus 2n, because we're adding the powers, equals, and then we want to make 36 into a base of 6. So it'd be 6 squared. So once we have the same base on both sides, get rid of the base. Set the powers equal to each other. So negative 5n equals 2, or n equals negative 2/5. Okay? So we had to create the same base and then follow our exponent rules. Number 2 is going to be very similar. So we're going to add, when we're multiplying, we add the powers together, negative 2n plus 2 plus n, and then 64 is 4 to the third power. So we get that, and we can cross out the bases, and these ones don't show very good, so I'm going to negative 2n plus 2 plus n equals 3. Negative n plus 2 equals 3. Negative n equals 1, or n equals negative 1. So once we get the bases the same, it's very simple. Alright, 16 and 64. What should be our base that we're looking for? It's not going to be 16, because 16 squared is definitely not 64. So the one that we want to use is 4. So 4 squared is 16 raised to 3x plus 3, and then 4 cubed is 64, all of it raised to the 2x. So now we have the same base. With power to the power, we multiply those. So on the left hand side, we're going to have 6x plus 6, and on the right hand side, 3 times 2x, which is 6x. And then we can solve for x. And so when we do that, we end up with 6 equals 0. Well, that's a false statement, so we have no solution. Hopefully you understand, hopefully you see why that works. Power to the power, you multiply the powers together. Then we have the same base, so we get rid of the bases and set them equal to each other. Okay, number 4, we have 3 different bases. We want to have one base. And so as you look, you can see 2 is going to be the base we want to use. So we're going to have 2 to the 5x times, so 2 to the 4th is 16, raise that to the 1 minus x, and then 2 squared raised to the x minus 3. And once we get all the same base, we can drop the bases. Drop the base. So over here we have 5x, and then we add them, plus 4 times 1 minus x equals 2 times x minus 3. So 5x plus 4 minus 4x equals 2x minus 6. And then we're just solving for x. So over here on the left hand side we have x plus 4, right hand side 2x minus 6. When we add 6 to both sides and subtract x, we end up with 10 is equal to x. And so we start out with 3 different bases. We have to get the same base, and so the easiest one to get is the base of 2. And then we just follow power rules at the top of the page. So make sure we're looking back at the power to the power rule and the multiplication rule. Those are 2 things we always have to look at. All right. Number 5, a couple different ways we can do this one. I'm going to do it straight powers. So 60, I'm going to use 4 as my base. So 4 to the 3rd times 4 to the 3x equals 4 to the 3rd. So when we multiply, that means we're adding. So 4 to the 3 plus 3x equals 4 to the 3rd. We can cross out the bases. 3 plus 3x equals 3, or 3x equals 0, which is x equal to 0. Okay? So we had 2 different bases we want to use one base. Now, this last one, I usually ask this one in class because people get confused, but it doesn't work as well when we're not all together. They have the same base, and so 1 minus x equals 1 minus x. If we subtract 1 and add x to both sides, we have 0 equals 0. And we would say that is a true statement. So the answer for x is all real numbers. X can be anything. And so that is solving exponential equations without like bases, or solving any exponential equations.